In most practical problems in statistics, you have to decide which statistical distribution to use. In some cases it is specified in the text of a problem, however more commonly that's a decision you need to make. In this first recording on choosing the correct distribution, we will look at how to decide whether to use the binomial distribution or the Poisson distribution in cases where one of these two distributions is appropriate. So let's start off by just looking at some general characteristics of each of those type of distributions. First, the binomial distribution. Assume x is a Bernoulli random variable with values 0 for failure and 1 for success. A Bernoulli trial is repeated n independent times. That is, n is the number of trials. There is a constant probability of success, p, and x is defined as the total number of successes out of n trials. In this scenario, x is a binomial random variable, and a key word here is probability. Another thing to notice is that the parameters here are p, which was the probability of success, and n, which is the number of trials. Let's contrast this with the Poisson distribution. With the Poisson distribution, events occur at random, but with a constant average lambda per some unit, where this unit could be time, for instance, or length, or area, just for a few examples. X is then defined as the number of events that occur per unit. So in this case, the parameter for a Poisson distribution is lambda, and the key word is average when you're looking at whether something is a Poisson distribution. So let's now look at a couple of examples. Here is our first scenario. The probability to win in a fundraising lottery is 0.3. What is the probability that exactly 2 out of 5 tickets win? Now this one we have to use binomial distribution. Why is that? Well, let's have a look at the information we're given. First of all, we're given a fixed probability that something happens. So this is a probability of a success. So here p is equal to 0.3, where in this case the success would be to win in the lottery. Then, looking at the rest of our information, we're wanting the probability that exactly 2 out of 5 tickets win. So altogether, there is n equals 5 trials, where here the trials represent the tickets. We are wanting then the probability of exactly 2 winning tickets. So the probability that x equals 2. I'm not going to calculate that probability in this recording. We do have subsequent StatsCasts on calculating probabilities directly in binomial and Poisson distributions. Here our main focus is on making sure we use the appropriate type of analysis. So keeping that in mind, let's move on to a second scenario and decide whether it's binomial or Poisson distribution. In this case, we're told that a primary school teacher reports that on average there are 6 students who are late for the first lesson per day. Find the probability that in this class there are at least 7 students who are late for the first lesson on a randomly selected day. So what do we notice here? We're talking about an average. So in this case we actually have to use the Poisson distribution, as this example gives an average rate. In this case, the number of students who are late for the first lesson per day. The parameter then, in this example, is the average lambda equals 6. And we're wanting to calculate the probability that the total number of events that occur, that is, children who are late for the first lesson on a randomly selected day, is greater than or equal to 7. Since we wanted at least 7 students late. So therefore we would be calculating the probability that x is greater than or equal to 7. Now there's one other thing we need to consider in making sure we use the correct distribution and tables to calculate probabilities, and that is whether we're dealing with a PDF problem or a CDF problem. First, PDF. That stands for probability density function. And for a discrete probability distribution, such as the binomial or Poisson distribution, the PDF gives the probability that exactly X events occur. So that means it'll be of the form probability X equal to some particular number. While CDF stands for cumulative distribution function, and the CDF tells us the probability that less than or equal to X events occur, meaning that more generally, with one extra calculation step, the CDF can also be used to tell us the probability the number of events that occur will be within a given range of values. So let's just return to our two examples to see whether each of them was PDF or CDF. In our first example about tickets in a lottery, we wanted the probability that exactly 2 tickets win. Probability X equals 2. So therefore that would be a PDF problem. By contrast, if we look at example 2, there we wanted the probability that at least 7 students were late, which was the probability X greater than or equal to 7. So that means that this was a CDF problem, and in fact we would need to adjust our tables a bit, because the tables would give probability X less than or equal to certain values. So in fact, since this distribution is discrete with only whole number values in this case, it would actually be calculated from tables as 1 minus the probability of X less than or equal to 6. However, more detail on that in subsequent StatsCasts on doing calculations of this type from tables. But in summary, just looking at our decision-making procedure for what distribution and type of table to use, first of all we looked at whether our distribution was binomial or Poisson. We then look at whether it is PDF or CDF, and as we went through the problem we wrote down the parameters, and with these pieces of information we would then be in a position to calculate the required probability.